Okay, welcome back, everybody. Hope everybody's doing well. This is going to be the next part of our unit. We're going to move on to talking about chemical and physical changes and chemical and physical properties, and then maybe go on to a little bit of mixtures. So this is the next installment of your notes. So definitely want to pay attention, keep it going. We got this, best we can do. So just let's do it. So we talk about chemical versus physical changes. We talk about changes with matter. We want to think of it, really answer the question is when this change is being made or taking place, is it changing the substance? So that's going to be really the question that you really want to ask is, when you do this change, are you changing the substance itself? Are you changing what it's made of? Are you changing its identity? Okay, so if the answer is going to be no, okay, then that's going to be a physical change, okay, some type of physical change. All right, so that's what you kind of really want to get that idea from this. It's really kind of easy if you think of it that way instead of memorizing a lot. If you understand what a physical change is you can kind of feel it that way. All right, so some physical properties. Physical properties are going to be properties that you study, okay, without changing the substance. Okay, so you're not going to change the substance at all, but you're describing it. What kind of things can you describe about something without changing it? All right, and a couple of interesting ones maybe we could think about maybe, and you have some lines here, so I'll put out the lines here that you could write on, and you have these in your notes. But some things you can keep in mind. You can come up with these on your own. I'm just going to list them in some type of order. Some properties is like melting point, right? So melting, I'm going to write them myself. Melting point would be a good one, right? Okay, in a way. So you could check the property of melting point, and you don't have to change the substance, right? You may have said something, maybe hardness. Okay, is a physical property. Maybe how something smells, the odor of something is a physical property. You don't have to change it. Okay, the texture of something. Okay, could be the same, this kind of thing, and even something like density. Density is an interesting one because density you can measure about the substance without changing it, right? Because density is going to be the mass of something over the volume. Again, you don't have to really do anything to the substance. You don't have to destroy the substance to do this. You could just, do it that way. All right. So if we talk about physical changes, some physical changes are things you can do to change a substance, but change it in a form way or a physical way, but the substance is still itself. Okay, and again, we have maybe a couple of different ones here, or three or four. A good change is maybe melting. Sorry about my handwriting. Melting, any phase change, really, right? You can go opposite that one and say freezing. My handwriting will get better. Okay. One interesting one you want to be aware of is maybe dissolving, right? Dissolving is a big one because dissolving, I want you to star that one because that's a little bit tough to understand sometimes. Like when you dissolve sugar in water, you still have the sugar and still have the water, but the sugar appears to disappear, but the sugar is actually still there, right? So we have to think about that a little more on dissolving on another day. Okay. How about crushing? Maybe if you crush something or you cut something up into pieces, that would be a physical change. Now, if you do change a substance, then you have done a chemical change, and a chemical property or a chemical situation is when you do change it or something, how something reacts with something. So the key word here is some type of chemical reaction, like we talked about before, the rearrangement of particles to something new. All right. So again, a couple little things here. Whether you react to something, you can use the word reacts. I know that reacts is something we used. Um, or something that's inert or doesn't react. Okay, is something you could say about that kind of physical change. All right, and if you come up with something else, we'll just leave that blank for now. All right, in a chemical change, these can be confusing too, but you have to think about when I make a change on the substance, am I actually changing it? What am I actually doing when I do this? So I'm going to put a few down here. These are ones, again, you want to ask the central question up here. This is really the question you want to ask regardless of what happens. The word decomposition is important when you decompose something. Decomposition or decomposing. Exploding or explosions, okay? How about combustion or burning? combustion, and burning. Okay, sorry, it's off the page here. That's going to be like that. Okay, and then some people also say rusting. That's a good one. Okay, and we can say oxidation. That's the same thing. Okay, or similar to it. All right, so really, these are words that you can describe. Even growing is a good one. Some people say, okay, growing, when a tree grows or you grow, growing is another type of chemical change. All right, so you can see physical changes. If you're chopping wood, but the wood is still wood, and the chemical changes would if you were actually burning that wood. All right, so it's not very hard. Something you can go through really quickly. The next page is really just practicing this a little bit. Okay, melting point again would be physical change, right? Flammability, chemical change, right? Density, do you have to change the substance? No, I don't. Physical change. Something that's magnetic. If you check if something's magnetic with a magnet, are you really changing it? No, so it's going to be physical. Tarnishing in air. So if you have a silver chain or something that tarnishes, that would be a chemical change because you're changing the substance, changing the chain to something different. Okay, chemical or physical changes, or I'm sorry, changes. We talked about properties before. Okay, mulching leaves. Again, another word, mulching sometimes drives people crazy. But mulching is when you chop up something. So if you're chopping up, if you chop up, writing here is my pen. There it is. Sorry. Get my pen. Sorry. Okay, so chopping up something or mulching is going to be physical. Souring milk. The milk is changing chemically, so it becomes chemical. Making wine, if you're crushing the grapes, that's different. But if you're actually making the wine, you're producing alcohol from sugar, that's going to be your chemical change. Melting ice, so you're really changing water? Well, you're changing it physically. Soda going flat, maybe the carbon dioxide's coming out, right, as bubbles, but you're not really changing anything. That's going to be physical. Leaves changing color is interesting. You're changing the chemical nature of the leaf, so it's chemical. And again, sugar dissolving is the sugar does not change, right? So that would be physical. All right. As far as signs of a chemical change, now this is going to be interesting here because how do you know that a chemical change actually takes place? So if you said chemical to any of the ones that are up here, how do you actually know that this takes place? Okay. And one of the things we do is a change in color or odor. So that's going to indicate to us, hey, maybe a chemical change is taking place. It's going to be interesting. All right. Formation of a gas. Whenever you see bubbles coming out of something, when you mix it or there's a change being made, that's a good indication that you have a chemical change taking place. All right. Formation of a precipitate is a solid that forms within a liquid or from a liquid. So if you look at this diagram here, you can see there's a liquid in here. Okay. There's a liquid here, and there's also a liquid within this pipette. No, sorry, I spelled it wrong. Liquid in this pipette. Now, as soon as this liquid touches this liquid, you can see that a solid is forming here. All right. And if a solid is formed, that is going to be something called a precipitate. All right. And that becomes a new substance. All right. So a precipitate, and it kind of gives you the idea of like falling out this way. So as you fall out of this becomes a new substance that becomes a precipitate. Okay. And last but not least, and this is something we see usually, this is a telltale sign, is any type you have some type of energy change, whether it's light or heat. Okay. And that could be happening here. You just might not know it in this picture. Okay. So 4 things really. Do they all have to happen? No. Do some of them have to happen? Maybe. Okay. So you really have to depend on the reaction. Sometimes it appears that none of them happen, and you really have to look at it very closely and give it some tests. Okay, so that's your chemical versus physical properties and changes. All right. All right, last thing here is something called a mixture. Okay, and a mixture is not a pure substance because in a mixture, if I go back a minute, if I say pure substances, remember pure substances are what? Those are pure. They're made of one thing all the time, and they're set by nature. So, for example, water is set by nature, right? You're not going to change it. That effect is H2O. There's nothing else there but water, right? But if you have a situation where you have a mixture, you're going to have a physical combination of multiple things, okay? And this is really interesting because there's an infinite number of mixtures, right? There's not an infinite number of elements. We have about 118 elements. I guess you can keep making compounds, but compounds have to have certain, rules to them. Okay, so if we have a variable composition, okay, and again, understand that variable means that you can change. So if you want to add that to your notes, it's a good idea is to think about variable meaning change. So you can change the composition of the parts in the mixture. You can't change the composition of water, right? It's H2O, which would be a set composition. All right, so that's the difference here. You got to remember that. Okay, you can be created or separated without a chemical reaction. If I gave you a mixture of M&Ms, you can pick out all the blue ones. You can pick out all the green ones. You can pick out all the orange ones. So you can do that without a chemical reaction. Okay, now two different types of mixtures. One is called a solution, and that would be homogeneous. And a homogeneous solution or a homogeneous mixture is one where the molecules are all evenly spread out. It looks like one phase. Okay, the parts are completely dissolved, so everything's completely dissolved in one another. Okay, you're not going to see any visible boundaries typically in a mixture that's homogeneous. Again, homogeneous prefix homo means same. Homogeneous means spread out. Homogeneous means, again, one phase. Okay, water solutions are very special. They're going to have something called an AQ in their formula. And that simply means, and a good example of this is glucose water. So let's just say I have some glucose and I dissolve glucose in water. So the glucose is C6H12O6. Now, if I want to tell, now that's the compound glucose. If I want to tell you that glucose is being dissolved in water, I'm going to take this little AQ designation and I'm going to put that down here. And that simply tells the reader that glucose is dissolved in water. Okay, and this means aqueous. Aqueous. That's what that means. An aqueous equals water. Okay. So C6H12O6AQ simply means that you have a sugar mixture of sugar and water. And that's why it's a mixture. Now, it doesn't tell you how much water, and it doesn't tell you how much sugar. So it really doesn't tell you that much. It just tells you that it's a mixture. Okay. Okay, you can be in any phase. You can be solid, liquid, or gas. Okay. Water and salt in a homogeneous mixture here would almost be like NaCl, and you guessed it, AQ, parentheses. Okay, this would be 14 karat gold. All right, that would be interesting, right? 14 karat gold, okay, carat gold is a mixture of different metals and gold. Okay, all right, so you got those that'd be your mixtures or your. Now, what if you can see the boundaries? And this is a lot of mixtures, and many mixtures are like this. Your set of keys is a mixture. You are a mixture. A bag of chocolate chips is a mixture. Soup is a mixture, right? Those are mixtures too, but they're not completely dissolved, and there's definitely boundaries. So we're going to call it a heterogeneous mixture. Heterogeneous means different phases. So you're going to have a non-uniform composition. You're going to be able to see detectable boundaries. Okay. Good examples of these is soil, oil, and water mixtures like Italian salad dressing. Okay. Milk, okay, is a good example of, again, milk is sometimes tough because you have very small particles. All right, I can't really write there. Milk is going to have very small particles. So it's very tough to tell sometimes with milk. Okay, so here's a good example of a rock that has these different crystals in it, and you can see the detectable boundaries. So that would be a heterogeneous mixture. Here's some sand. Here's some sand with some water, and this is H2O here, and then some oil. So the oil, you can't really see the writing here. It's hard to see, but oil is floating on top of the water, which is floating on top of the sand. You can see the layers of the boundaries in between them. Okay, and that would be a heterogeneous mixture. Okay, you can test this by shining a very, very strong light. This is a beam of light shining through these two mixtures. And look what you see. Here you see the beam of light, but here you don't. So in here, you're going to have particles that are in here. So that would be a heterogeneous mixture because the light is actually bouncing off particles that are actually in the mixture that is tough to see. Where here, light is passing through this completely. So this would be homogeneous. Okay, so it's a good way to test homogeneous versus hetero. All right, so really quick thing on mixtures. The main idea, however, is up here. Physical combination, variable composition, Okay, and there's two types of mixtures. Okay, all right. So to kind of like quiz you a little bit here. All right, let's go back. Sorry, my mistake. Okay, on this end of it, you're going to see blood here. Blood would be considered heterogeneous because there's different parts that you'd find in blood, right? So that would be a heterogeneous mixture. Urine would be, I hope it's homogeneous. Hope you don't have heterogeneous urine. That would be bad. Okay. Urine is going to be homogeneous. A T-bone steak, that would be heterogeneous, right? Because you can see the T-bone in there. Gasoline would be homogeneous. A Twinkie, heterogeneous because you see different parts of the Twinkie. Okay. Notice that I'm not using a lot of formulas here. So that's a good indication on the mixture too that you're not using formulas. Salad dressing, heterogeneous. Kool-Aid in water would be homogeneous because you stirred it up and dissolved it. There's the AQ, AQ automatically meaning homogeneous. Concrete itself, heterogeneous. Filtered seawater, homogeneous as well. Okay. So if you take a look at this review here of matter in general, if you start with matter and we ask yourself the question, does it have a defined composition? Is it set? Is what it's made of set? If it is, then it's going to be a pure substance. Now, pure substance can be either things. They can either be compounds. If they can be decomposed and taken apart, then they would be a compound. If they can't be taken apart, then you have yourself an element. All right, and again, you're doing this chemically. On the other side, if you have a variable composition, again, this would be variable comp. You probably want to add that to your notes if you want. Okay, then you would have a situation where your mixture can vary. If you are even throughout and homogeneous, and the answer is yes, then you would be a solution. Okay, and if not, you would have a heterogeneous, and you can think of this as having boundaries in the mixture. Okay, so again, there's examples of this that we'll see in class as well. All right, just last thing on this is important to note here, and I didn't mention this before, that compounds and elements by nature have to be homogeneous. I mean, think about that, right? Because if you're saying something's pure, then it has to be even throughout. It has to be made of the same thing. And if you're made of the same thing and you're even throughout, then you must be, by default, homogeneous. So pure substances have to be homogeneous. Mixtures have a choice. They could be homogeneous or heterogeneous if you see the boundaries. All right, so it's worth it to go and practice this. Again, there are some homework pages in your packet we will get to, okay, and these will quiz you on this. You can always go back and take a look and see what we're doing as far as looking at this lesson again. All right, so that's going to be it for me on this one. That ends the introduction to matter, and then what we will do is move on to formulas, but we'll stop here, okay? Have a great day. Hope things are well, and please contact me if there's any questions. Take care.